NASA just contracted a robot army to build the moon base, and the first human won't arrive until the machines are finished. We always assumed it would go the other way. Astronauts in space suits, engineers with wrenches, mission control watching from Houston. The image of humans building our future in space is so deeply baked into the story that almost nobody stopped to ask, what if the robots get there first? What's actually happening right now, with signed contracts and delivered hardware, looks nothing like that original picture. The machines go first, the humans come later. And these machines are specifically being designed so they don't need anyone watching. In the next 12 minutes, you'll find out how 3 simultaneous programs, one from NASA, one from the European Space Agency, and one from a robotics lab in Japan, are building an interlocking autonomous construction force for the moon. 2 of those contracts landed in the same 2-week window. One of those machines can reconfigure its own body depending on the task. One can turn moon dust into solar panels. And the question none of the press releases answer is, what happens to the human role when the robots learn they don't need a signal from Earth? The moon base robots are real. The hardware exists. 2 of the 3 major systems were delivered or contracted within the same fortnight. But the question that actually matters isn't whether robots can build on the moon, it's whether they can do it without a human in the loop. That answer came from a paper published on Archive in December 2025 that almost nobody outside aerospace engineering noticed. We're going to talk about it. Let's start with what dropped first. 2 weeks ago, NASA tapped Blue Origin, Jeff Bezos' rocket company, to deliver lunar rovers for its moon base initiative. The mission design is specific. Blue Moon landers will carry 2 robotic vehicles, one built by Astrolab, one by Lunar Outpost. Firefly Aerospace will separately deploy rocket-powered drones as aerial scouts. 3 distinct robotic systems, 1 coordinated mission, 0 astronauts. These machines will reach the lunar surface before any crewed landing, survey the terrain, test the soil composition, and begin staging construction materials for what comes next. That same week, Redwire Space delivered a robotic arm prototype to the European Space Agency. The arm, called the Argonaut Manipulator, is designed for ESA's Argonaut Lunar Lander. ESA Director General Joseph Aschbacher opened a €68 million call for the production version immediately after Redwire, led by CEO Peter Canito, proved the hardware works. The arm's primary function, cargo handling and rover support on the lunar surface, not science collection, not sample return, infrastructure work. So in a single 2-week window, NASA and ESA both moved forward on robot-first lunar construction. That is not a coincidence. That is a coordinated industry signal. Here is what makes it significant. Neither of these systems was framed as support equipment for human astronauts. Both were described as primary infrastructure. The robots aren't the crew's helpers. In the first phase of moon base construction, the robots are the crew. And this is the part that almost nobody is paying attention to. Before we get into what these robots can do, we need to talk about the problem that makes this harder than it sounds. The moon is 384,400 kilometers from Earth. Radio signals travel at the speed of light, and even at that speed, a signal from Houston takes 1.3 seconds to reach the lunar surface. 1.3 seconds, one way. 2.6 seconds, round trip. That sounds like nothing until you try to remotely pilot a robot through a boulder field in real time. You push a joystick, 2.5 seconds later, the robot responds. Except in those 2.5 seconds, it already drove into the boulder. Every rover NASA has ever sent to another world, Spirit, Opportunity, Curiosity, Perseverance, operated on a plan and execute cycle. Scientists upload a day's worth of instructions overnight. The rover executes the plan the following morning, then waits, then uploads the next plan. That is why Curiosity drove an average of 30 meters per day on Mars. 30 meters per day. If you build a moon base using robots that run on Earth-controlled instruction cycles, construction will take decades, which is exactly why a team led by researcher Kentaro Uno at Tohoku University published a paper in December 2025 that might be the most important document in the entire moon base conversation. The paper is called MoonBot, Modular and On-Demand Reconfigurable Robot Toward Moon Base Construction. It's on Archive reference 2512.21853, and nobody outside aerospace robotics read it. MoonBot is not your grandfather's rover. Here is what modular and reconfigurable actually means in practice. The robot can change its own physical configuration on the fly based on whatever task it is currently doing. Think of it like a Swiss Army knife that opens its own blades based on the job. Except it weighs roughly 200 kilograms and it's working on the surface of the moon. The system can transition between a wheeled ground vehicle, a multi-arm assembly platform, and a load-bearing structural support depending on what the construction phase requires. The critical detail, MoonBot is designed to operate autonomously, not remote-controlled from Earth, not supervised in real time. The AI inside makes its own decisions based on local sensor data without waiting 2.6 seconds for a signal from Houston. That is not science fiction. That paper was submitted in December 2025. The technology is being built right now. Here's the obvious question. If MoonBot can work autonomously, why do we need the NASA rover contracts at all? Why not just ship 50 MoonBots and be done? Because autonomous AI is brilliant at executing defined tasks and catastrophically bad at anything outside its training environment. The moon has craters, loose regolith that shifts like talcum powder, temperature swings of 270 degrees Celsius between lunar day and night, and geological features that have never been mapped at the resolution you'd need for autonomous construction. You cannot send autonomous construction robots into an unmapped environment. They'll get stuck on the first rock they didn't expect. The survey rovers go first. They map the terrain at centimeter resolution. They identify the flat, stable zones where structures can be anchored. They stage the initial materials. Then the autonomous construction systems come in with a complete environmental model already loaded. The NASA rover contracts and the MoonBot architecture aren't competing approaches. They're layers in the same system. Here's where the story gets genuinely strange. One of the biggest constraints on any moon base is materials. Every kilogram you launch from Earth costs between $2,000 and $10,000 depending on the rocket and the mission profile. A pressurized lunar habitat module weighs roughly 10,000 kilograms. Do that math and shipping costs alone hit $100 million per module before you've built anything. So in September 2025, Blue Origin, yes, the same Blue Origin that just won the NASA rover contract, announced that its Blue Alchemist system had hit a major milestone. Blue Alchemist takes raw lunar regolith, the gray dust that covers the entire lunar surface, and converts it directly into solar panels and structural metals. No water required, no Earth-sourced materials. The robot eats moon dirt and produces its own power source and building materials on site. A robot that manufactures its own infrastructure from local materials is not a construction machine. It is a civilization seed. And Blue Origin is the company building both the delivery vehicle and the resource manufacturing system. That is vertical integration of the lunar supply chain. And this is the point where the story stops being about robots and starts being about something considerably larger. NASA's position as the undisputed global leader in space has been eroding for 10 years. China's Chang'e program is funded, operational, and accelerating. Chang'e 6 landed on the lunar far side and returned samples. In 2024, a technical first nobody else has done. The Chinese National Space Administration has published a timeline targeting a permanent lunar base by 2035. Their robotic rover program is specifically designed to support that construction phase. This is a race, not a race for flags. We did that in 1969. A race for the resources that will define who controls the cislunar economy for the next century. At the lunar South Pole, there are permanently shadowed craters containing an estimated 600 million metric tons of water ice. That ice can be split into hydrogen and oxygen rocket propellant. Whoever builds the extraction and processing facility first has a permanent refueling depot at the edge of the inner solar system. Every mission to Mars, to the asteroid belt, to anywhere beyond Earth will want to stop there. The robot army NASA is building isn't just a science program. It is a strategic move to establish infrastructure dominance on the moon before a competitor can. The timeline on these contracts isn't determined by engineering schedules. It's determined by geopolitics. In February 2026, Elon Musk posted a detail that most people missed because it was buried under a SpaceX update. He said SpaceX is targeting a self-growing lunar city within 10 years. Not a station, not a base, a city, self-growing. The city builds itself. The architecture he described is essentially identical to what NASA and ESA are funding: autonomous robotic construction, in-situ resource utilization from local materials, and Starship as the heavy lift delivery system. Two of the world's largest private rocket companies, Blue Origin and SpaceX, are both converging on the same architecture for autonomous moon-based construction on overlapping timelines funded by a mix of NASA contracts and private capital. That has never happened before in the history of space exploration, not once. So let's answer the question the Hook raised. Can robots build a moon base without human supervision in real time? The answer as of 2026 is partially, and that partially is closing fast. The survey layer Astrolab rovers, Lunar Outpost buggies, Firefly drones still needs human mission planners uploading instruction sets from Earth. Strategic decisions come from Houston, the robots execute locally, handle obstacle avoidance autonomously, but the daily plan is human-authored. That is the current state of the technology. MoonBot's architecture changes the second layer: autonomous construction robots that select their own physical configuration, execute multi-step assembly tasks, and respond to local conditions without a round-trip signal. The technology is at the prototype and paper stage right now. It hasn't been deployed on the moon, but the deployment window is the same window as the NASA and ESA contracts, the late 2020s to early 2030s. Blue Alchemist adds the third layer: autonomous resource manufacturing. A robot that produces its own power and building materials from local regolith is not dependent on Earth supply chains at all. It is the first genuinely self-sustaining robotic system for a planetary surface. Stack all three layers and you have a construction force that surveys autonomously, builds autonomously, and manufactures its own materials autonomously. The end state of this architecture is a moon base that was built by robots, powered by robots, and maintained by robots, before the first human ever walks through the airlock. In the entire history of human civilization, we have never done that before. Every city, every road, every piece of infrastructure, we built it ourselves first. We are now designing machines to do that founding labor on another world without us being present. That is genuinely new. And here is the uncomfortable implication at the center of it. Those machines will be better at the moon than we are. They are better at it by design. Lower gravity, hard vacuum, 270-degree temperature swings, radiation levels that would kill an unsuited human in hours. None of that is a problem for a robot. A human in a pressurized suit on the lunar surface has roughly 8 hours of consumables before the suit is depleted. A Blue Alchemist system has as many hours as the sun provides, which on the lunar surface at peak exposure is 14 continuous Earth days. So, what is the human role in this moon base? The honest answer from the engineers building these systems is science that requires judgment, decision-making under uncertainty, and the diplomatic and legal questions nobody has resolved yet. Who owns the water ice? Who gets the refueling rights? Who decides what the robots are allowed to do when two nations' systems end up in the same crater? Those are not engineering problems. Those are human problems. The robots build the base. The humans come to govern it. There is a version of this where it ends well. Machines do the dangerous, back-breaking, irradiated founding work. Humans arrive on the moon to a functioning habitat, pressurized, powered, with a landing pad already waiting. Nobody dies building the place. But the question that follows immediately is, if autonomous machines can build a civilization on another world without us watching, where else can they do that? And who decides whether to ask? That question doesn't have an answer yet. But the contracts are signed, the hardware has been delivered, and the launch windows are already on the calendar. Subscribe if you want to follow where this goes.